As such, the exercises are laid out for each of these topics on how the PMs are triggered. In exercise 1, it is machine usage. In exercise 2, it is condition assessment. Exercise 3A illustrates a simple predictive technique. Exercise 3B is advanced predictive with machine learning algorithms. But before we get to the advanced machine learning techniques, we first look at as an example when PM versus repair cost is given and how you quantify the benefits of moving from corrective to preventive to predictive. And we do have detailed examples on the machine learning techniques, but those are out of scope for this lab and available separately. And exercise 4 is for the last topic, asset health score. We need to clear up some terminologies. What is process data vis-a-vis what is machine condition data? And in the PI system context, process data is continuous data and comes in very frequently, every second, every 5 seconds, every minute, etc. Pressure, temperature, flow rate, equipment states available from the SCADA, open, close, running, stopped. And it can also include measurements from the newer IoT sensors and gateways, plus data from other sources such as safety systems, environmental monitoring systems, and others. Machine condition data usually comes into PI less often, and often they are in their own databases as part of a separate system. And the data is different. Vibration, infrared from the thermal guns, motor hotspot, junction boxes, oil analyses, particle and metal content, motor current, and so on. Most of you have seen this or a similar slide showing the PI system components and the data flow. Suffice to say, in all the exercises, we use out-of-the-box PI capabilities, and if there are exceptions, we will point those out. Of course, the machine learning portion in advanced predictive uses external open source libraries. And in visualization, we do show the use of some custom widgets, but it is there more to illustrate PI Vision extensibility. And most of you also know this data flow sequence. Collect the data, define the context, which is mostly AF data models, do the calculations, we are referring to asset analytics, visualize in PI Vision, then share, notify, and act. It is highlighted because it is easy to share hyperlinks with your maintenance counterparts and send a notification email about a machine condition to your Maximo maintenance planner scheduler. As an experienced PI user, it is trivial for you to cook up the PI Vision web pages and just send out the links to the asset owner. The last item is business integration, and this comes up every time we talk about PI system and work management systems such as SAP PM, Maximo, and others. It is mentioned here for the sake of completeness, and even though it is not part of this lab, hence it is in grayed out font, but resources are available and we can take it up separately. The step-by-step content in the exercises will focus on the items in this rectangle. Now, coming to the actual exercises, there are several examples where you can implement usage-based logic. We will illustrate with the top two. This shows where you start, the calculations, the PiVision screens, and the final output. And these are all examples of using some leading indicator for condition-based maintenance. And we will use the bearing temperature to illustrate this step by step. And this shows the data model, the AF analytics, the PiVision screens, and how you can create a watch list for the events with your asset. Exercise 3A is about simple predictive technique. And here the vibration data from a pump is used, and you take it through the analytics to extrapolate the trend to predict how long before it will violate the high limit, which gives you the remaining useful life. Exercise 3B on advanced predictive and exercise 4 on asset health score. We will pick up these two topics later in the course. The next section is the hands-on exercises 1, 2, and 3A.